I'll just share my screen. Uh, Please let me know if it's visible. Is it visible?
Yes.
Okay, right. Sure. So as of like last demo sessions, so we try to understand like what the problem we are solving and how are we planning to solve it, right? So we were more focused on so what we will be doing with this course and so with this course, what uh, does it allow us to like do, right? So from today, we will be more focusing on the curriculum which we have designed. Okay. So for that, in order to understand how to do the AI quality testing, so we have to particularly understand how AI actually works and what it is, right? So we will just go through a simple analogy, evolution of AI. Okay. So why it is called AI and what are the underlying terms into AI. Okay. So yeah. So AI is an uh, more of a larger term under which specifically machine learning comes in, and within which deep learning comes in, and a small part of it is nothing but generative AI. Okay, so we'll understand this. Okay, no need to hurry. So what we call in general AI, these are nothing but large language models in action. So what are large language models? So these are the models that are used by Gemini, okay, the ChatGPT. So there are different models which these particular brands are using, and so under the hood, it is all LLM model. Okay, so this is what we kind of say like for these models, we are particularly saying it to be AI in general sense. For a general consumer, this is what AI actually means. But as a technical subject is concerned, so AI is a much broader term than what it actually means for the daily users. Okay, for the non-technical participants. So let's understand how this evolved and what was the initial stage of AI. So this journey we can say. Okay, initially uh, the thought of AI came in like with Python, right? So in Python, we can use like if and else conditions. Okay. So let's just say we want to find an username that is Arya. Okay. So we will just write an if statement. Okay. With email if it is equal to Arya dot something. Okay. If so, if this is recognized, Arya is recognized, or else don't allow him for the session maybe. Okay. Okay, so this is the condition. These are like in if condition. If the condition works, then this particular logic will work. If it doesn't, if the condition fails, then this particular logic, which is in else part, does work. Okay, so this was a simple Python if else statements. So the initial AI was more of thought as like we could write if statement for many conditions. Okay, this is condition number one, and there is condition number two, and there is condition number three, and there is condition number four, and so on. So we thought for a particular application to work, we will write so many if statements such that we cover the whole environment. Okay. Let's just say if an email is, we have to classify an email. So let's just say we have to classify it as a spam or not spam, right? So we will write up so many if statements like if there is sponsor word is there, if there is like money word is there, if there is like simple discount word is there. So many words, right? So we'll write so many if statements with all that condition. Like if anything triggers, if the condition, if any of these conditions be successful, right? Then this that logic would work, and and this particular application, what we said. would classify that email to be like spam or not spam. So this was an earlier imagination of AI, okay, in the initial days, like let's say 1960s to 1980s or 1990s. Okay. So this changed with the second phase of AI. Okay. So where the introduction of machine learning came in. Okay. So machine learning. So we'll just highly like we'll get an overview of what it is and how it is solving the problem. So initially, at initial days, the AI was considered to be like so many set of if conditions. If any of these condition works, the logic works. And the thought was to cover up all the necessary conditions for an environment with these if conditions. Okay. But this was not useful because as we know, there could be multiple conditions, multiple different edge cases, okay, where we may not know how things work actually. So there could be an email where it doesn't allow any of these words, but still could be spam or some promotion. Okay. So then come machine learning. So what it does is, so we had a model, we had data. We started using data for this. Okay. Let's just say there are columns for the same. We will use the same example. We have to classify an email is if it is a spam or not spam. Let's say. Okay. And there are particular columns. Okay. So let's just say we took 1,000 emails, okay, and in each email, whatever the data is there, so let's say column one or characteristic one. So this is column two, characteristic two. This is column three, characteristic three, and so on. Okay, and the last one, last column is a target column where it is mentioned if that particular email was actually a spam or was it a not spam. Okay. So yeah, we needed to solve a problem where a set of emails were given and we have to classify that email to be a spam or a not spam. That was the we need to build an application for this. And we tried with checking with the words, but as we know, there could be like n number of edge cases and n number of words manipulation they can do, right? So we can't cover up everything in an if statement. So then come this machine learning where we are trying to teach the machines. Okay. So as we do for kids, right? So a kid doesn't know, may not know like if an email is a spam or not. By looking at so many examples, right? By looking at so many examples, he will find a pattern, right? He will find a pattern through which he can recognize if an email is spam or not spam, correct? So he will find a pattern by looking at these examples. Okay. By this logic, we try to create a like machine learning model where by looking at these characteristics, character one, character two, character three, character four, we are also providing it a target. That is, we are saying it loudly that for this particular set of characteristic, it was a spam. For the second set of characteristic, this was not spam. And like this, almost let's say we give 1,000 examples, 1,000 emails, the content, and let's say we are manually classifying it to be like spam and not spam. Through these 1,000 examples, this model is trying to find a pattern. Okay, through different algorithms, it is trying to find a pattern through which it can classify either an email is spam or not spam. Okay, so this is a classic example. Okay. So these models were trained for like binary classifications. Let's just say, will it rain or not rain? Okay. Should we give credit to this person? Yes or no? For these questions were being were trying to be like solved with this particular machine learning models. And there are like a number of machine learning models. Okay. So starting with the simple ones, we have linear models, which basically try to predict. So what's the next number? Let's say there is an IPL match that's happening and there is a score rate, okay, run rate that's been provided. So it is trying to, through previous so many examples, through so many match data, it has understood like when does the game turns or when it could get worse or something like that, okay. So through that data, now it is trying to predict in the live match whether there will be a wicket or the run rate will increase or decrease or something like that, okay. So it is trying to understand a pattern basically. So as you could see in this particular example, right? So considering the characteristics of email, it is trying to classify it to be spam or not spam. As simple as that. So it is trying to understand the pattern within the content of that particular email through which it is identifying few points, like let's say point number one, point number two, point number three. Okay. Since we are guiding it to be like whether by presenting it to be a spam or not spam, we are guiding it. And through these guidance, it is putting up its own patterns. And let's say it has given some values for this particular pattern. And if a particular email matches to this particular pattern, the chances of it being a spam is like 0.4%. And if it also matches to this particular pattern, the probability of that email being spam increases. Okay. And if it matches this pattern also, it is probably a spam. Okay. So this P1, P2, P3, we are not providing it. Okay. Through these characteristics, the model is internally identifying these particular characteristics, its particular patterns, and through which it is giving itself some value. And whenever new email comes in, let's say new email. So this is how your Gmail actually classifies spam or not spam.
Arya, I have a question here.
Okay.
Saurabh here. Arya, so we are providing a pattern, and let's say let's discuss about linear model. When we are providing a pattern and
Mhm.
we are training it, let's say this particular email is a spam, that particular email is not a spam. Then
Okay.
a third kind of email came which is nowhere related to any pattern, not even a
Yes.
spam, not even a not spam. In that
Okay.
case, how our model will identify based on the existing training data whether this is whether this is a spam or not spam? Like it's completely different. It's not related to any trained data. Not even, let's
Right.
say we have trained with 1000 data, it is not even matching with one data.
Right.
Then
Right.
how it will predict?
Yes. So yes, I'll just answer it once I complete this. Okay. Saurabh,
Mhm.
would that be
Sure,
fine?
sure, sure,
Yeah.
sure, sure.
So yes. So if a new email comes in, so it is trying to value this particular patterns, and then it is classifying if it is a spam or not spam. And what Saurabh got is an obvious question, right? So what if among these 1,000 emails, so let's say these were created in some 1990 and 2020, maybe the words or the pattern that's been like create that spam emails are different now, right? So whatever the examples that's been, it is not trying to copy examples. Okay, first of all, it is not trying to match this new email with this particular set of examples and then rate our spam or not spam. It is intelligently trying to find a pattern through which it can convince whether it's a spam or not spam. And let me say, so these machine learning models have got accuracy rates. Okay, so let's say a model is 90% accurate. Then if you give like 100 emails, 90% of it could be correct. So it can classify it to be correct. And 10, probably 10 of those emails, maybe it can classify it to be incorrect. Let's say they were spam. It may classify it as not spam. Okay. In real world, this number could get down to like 50 to 60% or 70%. Okay. Uh, so when the data set is too clean and there is a visible pattern, so this accuracy rate increases. But for the real world data where things get messy, so I have trained these models like I have got like 50, 60, 70% accuracy rates. Okay. So with a pattern, it is probably it is trying to classify. Okay, it definitely doesn't classify accurately 100% of the time. Okay, so depending on the pattern it has identified, it is trying to make a probable call. Okay, so let's just say the conclusion of this particular set is like zero point 0.6, that is 60%. Then the machine learning model may say this new email is particularly spam. Okay, if let's just say the probability has called like 0.4 for spam, then it may classify it to be not spam. So this is all probability. And underneath, it's the maths that's in use now. Okay. So coming to Saurabh's question here. So of course, right. So the new email comes in. Maybe it was relevant back then. This machine learning model, which was trained, was relevant back then. But as of 2010 or 2015, it has got a like great drawback. That is the example dataset didn't contain a pattern where like 2000 or 2010 emails does contain. Okay. For this particular reason, this model has to be updated in order to work for it to work for the current emails or the future emails. Okay. So in order to make it relevant, we have to provide more examples with the new data, and it will try to find this new patterns. Okay. And as of particularly Saurabh's question, so what if this particular model, if I give a new kind of email where it hasn't explored in its example data set, right? That's the question, right, Saurabh?
Yes, 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 yes.
Yes. So in this case, again, although it may not find any pattern, it is trying to make a probable guess out of this. Okay. So
Okay,
whatever the
okay.
pattern it has already like shortlisted, which it is looking for, if there are patterns similar to this, it may give a high probability, or else it may give a low probability. And this comes in like where the incorrect classification happens, right? So
That
it may
9
come in this
10%
category.
inaccuracy.
Yes, yes, yes. So this could be one of the inaccurate probabilistic classification. So basically, these models, which were like from 1990s to 2010, these machine learning models were specialized for this classification kind of tasks, or to find a particular predict a number kind of tasks. Okay, let's just say in a four subject, child has got some marks, and in the fifth subject, what he could get. So all this prediction. Okay, for real life example, I can say. So I worked on. So I took up Bangalore dataset. Okay, so basically all the places in Bangalore. Okay, the rent of that particular the land rates depend on the area, the quality of the area, and uh, how many companies are there, the landlords, everything. Okay. So I was trying to predict how much would the rent be if they want to particularly live in particular set of, let's just say this area. Okay. Considering area, the plot size they want to live in, if it is a 2 BHK or 3 BHK or 1 BHK, etc. Through these particular inputs, I was trying to predict what would be the rent of that particular like stay. Okay. So I had to from the Databricks, I downloaded like I have to scrape through all their data in Bangalore, and then I have to clean it up, and I have to create this data set where for this particular area, for this particular set of like area plot to 2 BHK, if it has got a balcony, how many bathrooms, how many bedrooms, what's the hall size, if the amenities were provided, if there are furnitures, वगैरह वगैरह, right?
Mhm.
So depending on all these factors, there were rent provided, and I had to train this model. And when the new user comes in, let's say new user comes in, and he puts up like his requirement. He wants this area rent in this area, and these are the amenities that he wants. Okay, so my model would predict what would be the probable rent for this. Okay,
Okay, okay.
so
And
this
this
is
is an
an
example
real
of
life
linear
example.
model. This is a linear model,
Yeah,
right?
yes,
Like
yes,
based on
yes. This
pattern,
is
it will identify the result.
exactly, exactly
So the core concept of linear model is defining a pattern.
right.
Okay.
Okay, and linear models are the simplest models. We have classification models. Okay, so this classifications model, as I gave like example of if a email is spam or not spam, if depending on weather, let's just say temperature, humidity, and wind speed, wind direction, all these factors, whether it will rain today or it will not rain. Okay, will it be sunny today or not, etc. So the classification need not be binary always. Okay, so the classification could be there could be like more kind of options. Okay, let's just say there is an option one, option two, option three, option four. So it tries to identify all the patterns that would point to these particular options. Right? So these are like classification models and the regression models or the linear models, let's say. Okay. So this is what like most of the machine learning was about. So we were trying to solve this particular, let's say this particular problem here. So what's next? So AI came in and there were like initially if else statements. Okay. And then came in the machine learning models. And what next? So next came in the deep learning models. Okay. So what is this deep learning? Somewhere, so the machine learning models were efficient with a simple structured data. Let's just say there are columns. Okay, we need to find a target value. So we have given like there are two types of machine learning models. So one is guided model. Okay, the other one is not guided. Okay, uh, so I'm not getting into like exact terms so that I don't overcrowd with the machine learning and all the AI and terms. Okay, so in particular, these are called supervised models, where a human is labeling the things. Okay, labels are given like spam, not spam, with the examples. Okay, so others were unsupervised models, where the label were not there, no labels were there. Okay, so the model has to identify through the example. So it has to identify a pattern and try to respond back. Okay. For unsupervised models, we can say there are set of libraries. Okay, there are set of library books. So this is for like horror books, and this is for science fiction, or this is like drama kind of. Okay, so we give a new book. Okay, so new book with this particular author and summary. So now this model has to put this particular new book into some category, right? So where would it be fit? Like in order to predict these, we had models. So these models were usually unsupervised models where we don't have to label the things. Okay, like spam or not spam, or will it train or not train? We don't have labels for it. It has to understand a pattern and the model has to train on a pattern. Okay, so these kind of problems were solved using unsupervised learning. So most of the machine learning applications are built on like supervised models. Let's just say 80% of the AI applications, machine learning applications, are of supervised models. Okay. So yeah, we wanted to get into a deep learning, right? So what is deep learning? What does it solve? So machine learning models were good, but for a complex pattern like understanding a human language. Okay, understanding a human language is complex, of course. So understanding a human language or to respond back, or if there are like complex patterns which need to be identified. So there machine learning had its limitation. Okay. For a simple structured inputs, machine learning was great, and machine learning is still great because whatever the models, the large language models we are saying, although they may be very powerful, they take time to respond. But machine learning models were very quick. Okay. So even now, these machine learning models are being used. For example, let's just say in shipments. Okay. Uh, it has to like pass through an ocean. The optimal, depending on the waves, depending on the speed of like wind, depending on the direction, depending on the like storm, everything, right? All these data. So the machine learning has to, these model has to predict the optimal path to reach the particular goal. Okay. So for all those, even now, machine learning models are being used. They are powerful when the input is, the training data is structured. Okay. So they are powerful then. What about deep learning model? So these were introduced with a complexity that it has to understand complexities, complex patterns like language and many more. Okay. So these were much heavier models. then the machine learning models. Okay. Uh, so what was the main problem it was trying to solve? Let's just say maybe the classic example would be like whatever you see in the cameras in the traffic signal, right? So it captures an image of that particular signal, and it recognizes whoever has wear the helmet and who are not. It recognizes the vehicle number. It associates that vehicle number with the particular owner. Okay, and it is saying it is recognizing that this particular rider has not wear helmets. Okay, so this is been identified through this particular picture. So how did we train a model to identify? How did we build this application to train a model to actually identify these particular things, right? So here we are providing set of photos. We are not trying to, let's just say, we are guiding a model to get the output whatever we need. Okay, so we will not give a label that this in this image particular person is not wearing a helmet, or in this particular image this person is not wearing a helmet. Okay, considering so let's say if we take a classic example, let's just say dog. There are 1,000 images of dog and 1,000 images of cat. Okay, now this new model has to identify whether the given input is a dog or a cat. Okay, so we will present this particular model with like 1,000 images of dog, 1,000 different images of dog in different pattern. Okay, and then 1,000 uh, images of cat. Okay, they may be like big cats or small cats or domestic, any pets. Okay, so all those cats, all those different dogs. Okay, so it tries to identify things like what could be the metrics, right? So basically size, depending on the size, depending on uh, the length of that particular animal, depending on face shapes, uh, depending on the weight, the characteristics, different characteristics. Okay, there could be n number of characteristics. So we are not giving these inputs specifically, unlike as we give in like machine learning models, but we are providing images of both the dogs and cats, and it is trying to identify a pattern. Let's say P1, P2, P3, P4. Okay, so it is not memorizing, but it is trying to figure out from the first image if this is dog. Okay, the second image that's dog again. The third image that's dog. So how many different types of dogs image does it got? And depending on these characteristics, it is trying to identify the input images, whether the dog or cat. Okay, these could be like I could show you an example. I'll just so this Kaggle is a very good website where you get like lots of data sets. Okay, imagine. So this is okay. Is it visible, guys?
Yes.
Yes, yes, visible.
Yes. So here you could see it's not a straightforward image that's been taken. Okay. So here it's a cat, it's a cat. So they are raw images like as someone takes in phone. Okay. All these images, as you can see, there are like manipulative images too. Like here it's a cartoon. It's not a dog or a cat, right? So identifying a dog or a cat for us, how do we think? Like we have seen dogs and cats throughout our life, depending on which we have understood a pattern. So our brain looks for a pattern, of course. So there it looks whether if it has got a like pointy ears, or it looks at the eyes, looks at the face shape, everything, right? So depending on this, we are instinctively trying to classify whether it's a dog or a cat. Similarly, so we are training this particular model where with so many weights, so many patterns. It is trying to identify the pattern, and through which it is trying to make sense out of this data. And with the input given, it is trying to classify it as like dog or cat. So this is classic example. Uh, these are majorly used for deep learning models, majorly used for this image classification and everything, because images are complex, of course, right? In order to understand a pattern within the image, that's complex task. And for this, deep learning models are much better than the machine learning models. Is it used for only this? No, maybe. Deep learning models are used for when you are using like Google keyboard, right? So whenever you say, let's just say, uh, you type in I love, okay, and below you may get like three suggestions. I love myself, I love science, I love AI, right? There could be suggestions. So whatever you choose, so these are possible words, right? So here, depending on like whatever the input is coming, first word is I, the second word is love. So what could be the next word? It is trying to predict the next word and it is giving you the suggestions. So this is also a deep learning model where it has understood how the language works. What could be the next word, right? So these are the possible words. It didn't give like I love is or I love was, I love it. No, right? Of course. So the predictable words it is giving us. So this is a pattern that it has understood through set of paragraphs or set of data that's been provided to it. Okay. So these are also deep learning models in action. So yes, so that covers the deep learning, and then came the Gen AI. Okay, which means generative AI.
Arya, is it also a model when we talk about Gen AI? Is it a model or it's different?
No, so deep learning was a concept where the
Okay,
models were being trained, right? Machine
okay,
learning itself was a concept
okay.
where the intention was to train machines. Okay,
Hmm.
make sure machine learn. So these were models again. So this machine learning is a concept. Internally, the models are being used. Again, even for the modern day AI, I say large language models, right? The name itself.
Hmm.
So those are internally models that's been trained on the data, and it is trying to predict the next word, right? So generative AI is a concept where uh, we were actually trying to generate something out of these models were trained to generate something. It may be text, or it may be image, or it may be video or audio, right? All this. So the generation is happening here. That's why these models are called generative models. And this is what generative AI is. So AI, the timeline of AI, this is all is an AI, right? So Gen AI is different. Gen AI is the modern day AI, what we are saying. So when somebody says AI, so they usually refer to this generative AI. They don't know the past AIs. So AI was always there, but it was popular because of the text generation that's been happening, right? So how these models? So machine learning models were simple models which were trained for like a simple data set. Okay, there is a structured input and it is trying to predict. Deep learning models were to understand the complex patterns. But this generative AI models, these models were actually much larger than these deep learning models, and they try to identify much more complex tasks. It try to solve like much more complex problems. Okay, like understanding a human language, right?
Arya, so when we have this new generation of AI, that's a generative AI, so are
Mhm.
these old models, like not models, older concept, machine learning or deep learning, are they
Right.
irrelevant these days? It's totally obsolete, or what do you say? It's still under use, but it's of like very less used because of their
Okay.
limitations. Like what is the current status of this deep
Okay.
learning machine? Yep.
So if you ask me, like, let's just say, so we all work in a company. Let's just say CEO is the like one who like has all knowledge. Okay,
Hmm.
although he may have all the knowledge, we still need so many other staffs, right, in order to
Mhm.
actually work with a company. So similarly,
Yes.
large language models are like powerful models which understand the generic patterns, which understand the language, which can generate things, right? But these comes with a pros and cons again. So the size, the sheer size of the model uh, is the problem. So what in the demo sessions I showed you like the model which were in my local, right?
Yes. Yes.
So if I had to run those models with the CPU, so I have a like powerful CPUs. But still, if I had to run with those CPUs, the generation speed what you seen in that demo sessions would have been like 10x. Okay, since I
Okay.
have GPU which do the parallel processing, I had this response much faster. Okay, but GPU storage is costly, right?
Yes. Yes.
That is way too costly. And fitting up GPUs in like let's just say there is a smart remote or a smart washing machine, that could be hard,
Yes.
right? So that's why there are limitations. Okay, so where we have to, depending on the input that's been provided. Let's just say that we have a simple classification where there is an structured data available, right? So here, instead of using large language models or deep learning models, machine learning models would be like would be much better. Let's just say if the data is limited, let's say we have 1,000 rows of data, and that's structured data. So machine learning would be my first choice. Okay.
Okay.
Let's just say I have like for deep learning, it takes like huge amount of input data for it to identify these all these patterns. So it
Hmm.
understand the patterns better, but it also consumes a lot of uh, training data.
Resource.
It needs like a lot of it's a data hungry. And in AI,
Okay.
it may be machine learning model or deep learning model or large language models. There is this rule that is uh, the input quality. If it is good, the output quality you can expect it to be good. Okay. So if you input trash, the output will be definitely trash. Okay. So we have to check through the input that's been provided. So let's say we have these large language models. We have few large language models which were trained on Reddit data, where
Okay.
just like Twitter. So uh, so the words are not professional enough. Okay. So this model actually trained on Reddit data learned how to cuss the users. Okay. So this is what if we give a trash as an input in order to train this model, the output would be, of course, trash. So we have to consider this input a variable. Okay. So if the model, if the input size is less and we have to use a predictive model, machine learning is my first go, and I have like a lot of data. We can go. I can go for like deep learning model where it identifies much more complex patterns. Okay. And as of generative AI, it's of more of a generic usage model because the sheer size of the word itself, large language model, right? It's a language
Yes.
model which is trained on like huge data set. Let's just say the whole internet. Let's say, okay. So that's why the sheer size makes it difficult to like apply for like faster responses. Okay. So all the three they exist in different domains. They solve different problems. So wherever the problem requires whatever the type of technology, we use it. And machine learning and deep learning are still there. Okay. Yep. Uh, okay. So generative AI, these LLMs, okay, large language models. So let's say how are they trained on? Similar to deep learning model, it is trained on like unstructured data. Or we get like we give a set of PDFs or a set of internet stuff, everything. Okay, and it is trying to make sense out of it. It is trying to understand the language. Okay, and it is trying to respond to the requests. So internally, machine learning model, deep learning model, GenAI model, these doesn't understand the language. Even now, whatever the model you consider, they doesn't understand what request you are providing. So uh, let me just clear up this. Okay. So there is user request. Okay. And the user request is tell me about stocks or let's say bikes or anything. Okay. So it is not understanding these particular statements because it doesn't understand the language, but it gives you a sense of like false sense where it make sure like you don't know like if this statement is being understood or not. Okay, it tries to respond in the language which you know. Like it may start with dogs are like best friend of animal, best friend of humans, blah blah blah, all that thing, right? So these input is being converted into a mathematical vector. Okay, so there is a set of numbers. Okay, this particular input is being provided as set of numbers, and it is the model is looking at these numbers only. And depending on whatever the input is being provided to that model, in its knowledge base, there are so many set of information that's been provided. So it tries to make sense out of like what is the user input is, and with its knowledge base, it try to make sense out of it. So whatever the relevant data is there, okay, and it tries to respond back in English. So it responds back with these models are tend to respond back with this particular vector, again the mathematical representation, and these are being converted to language which we do understand. Okay, internally this is the maths in is in use, and as of the like input we are providing and the output we are getting, that is plain English. Okay, so we'll look at like ongoing classes. We will look at how these models convert our English like into or any language, any user request into this mathematical form, and why this particular mathematical form, and how does it look, everything. Okay, we will explore more on this. Uh, so that would be beneficial for us to explore RAG too, which we discussed with retrieval augmented generation later. Okay. I will discuss on how these large language model actually work. Okay. As of today, I just wanted to make sure you understand AI is not uh, AI is not ChatGPT. Okay. Or Gemini or any other tools. AI is much bigger. It's a broader term, let's say. Okay. For general public, AI is nothing but ChatGPT. But as a technical users, we should understand AI is much broader term than just ChatGPT, and within which there are so many subsets. And generative AI is a small subset of deep learning superset. Okay, so this I wanted to show you. So tomorrow we will understand what these large language models are and how these actually work. Okay, what are tokens, how our requests are converted into these particular set of mathematical representations, how they are decided, and how it actually understand, how it pretends to understand our language, although it doesn't. Okay, we will look into all this as we go, as we try to understand the AI more. Okay, and we'll also look at the architectures of how these models are being built internally. Okay, and also in the earlier ChatGPT or even in the recent versions in any LLM models, you can see that first word is generated and the second word is generated after the first word and the third is generated, right? So it doesn't pop up like everything doesn't pop up like instantaneously. It's a sequential in on order that is being generated. So why does that happen and what it is, what we need to conclude from it? We will look into this also. Fine.